Hello everybody and welcome back. So we're gonna continue and do this setup. And in the last tutorial we made just this everything set up. The controller is giving this number, the count, and the circle is just the default quads, and yeah. So the first thing we want to do, that we want the distance between the particles and the player. And actually we can just change the particles to our beans that we have. This is going to be out mesh. So output particle URP lit mesh. And, and we have made the bean here. And important is to have this read write. So if you take the bean, you need to have read write on it like that. Apply, and then you just take the bean mesh and plug it in. So now we have the bean at least, and we have made the material. So we take this material here, and now we have the beans, black ones. So the first thing we can do, no, actually we're going to leave them black. The first thing, we want the distance, and the way to do distance is if we have the player position, and if we take the particle get position, if we get the position of the particle, then we do subtract, and we take the player position and subtract with the particle position, then we get the vector, and then if we measure this vector, we get the length between the particle and the player. So now when we have this one, we can just do a compare node, and then we do like this. So if the distance between the player and particle is less than 0.3 units, then this will return true. Otherwise, it will return false. So 0 or 1. Then we just do here. We need actually an... we can do it like this first. So I'm going to take it in steps so I don't confuse you too much. So if now the particle is alive, if we do like this, they will die. So if we do here again, you see, if we start, if this is ticked in, they are alive, and here they're dead. So we just need to restart the system. So that's why I'm clicking save. And so if the distance is shorter than 0.3, then it needs to be greater, like this. So if the particle is greater, then it will be alive. So now, if I take the player and move it around, you see now we're eating up the particles. And we're actually updating the particle count here. So this is super nice. So this is again after super basic how to set it up. And this is only to show how you can use the set live, and it actually works. We're actually not going to use it like this. What we're going to do is set the custom attribute. And this custom attribute, we're going to have it as a Boolean. So we're going to call it eat, like that. So if it's false here, then actually we can do get custom attribute. And we're going to fetch the eat attribute, and it's a bool. So whenever let's see here. So the thing is, when we have it like this, when the distance is more than 0.3, it's set to alive. But we're going to make like this. We're going to have this eat bool. So whenever the distance is shorter than 0.3, then eat going to be true. That means we have to change it to less. So when it's less than 0.3, then eat is true. And then we're going to have then we're actually going to move the particles to the number. So we're actually not going to use this one yet. We're going to do set velocity, because we need to, the alive node we're going to activate when the distance between the particle and the number is really short. So now we need to activate this velocity, because we don't want to activate it until it's in this radius. So this will only be activated until the player is close to it. So now you see the logic about it, right? So all these other black beans, they have this false here, but all the one who is going up, they have this one true. So this is a really nice way, because now we can decide when the particles are going to start to flow to the number. And the way we're going to do this, we again gonna use this time the number position. So if we just copy this part here, instead of comparing the particle with the player, now we use the number position, and that's the position where the number is. So then we do the distance of this one, and no, now I said wrong. We're gonna measure it later, but we're gonna do that not yet. So what we need to do now is to find each particle. They need to know the direction to 5000. So what we need to do, we need to take the text position and subtract it, the number position, subtract with this bean. Then we will have this direction, and we're going to use the direction as a velocity. So here we have, and the velocity is the force that we add to the particle in a certain direction. So in particle world, you have velocity as the kind of the speed when it moves somewhere. So here we do need to do set velocity. Oh, we had it here. Oh my god. So we have number negate with the position, and then we normalize this one. So now we have, if we do like this and save it, now you see it's actually moving towards, and continue. So that's the first step. And what we want to do, we want to get the last velocity value from the last frame, and then we want to add this new velocity, because the last frame before this gets activated, it's 0, and then we start adding this one up. So now it will start flying faster, as you see here. So let's see. I hope you follow along. It's gonna be a little bit tricky sometimes. So now we do need, we have this set value here. And here we need to do this oh my god, I almost lose myself here. This is so crazy. Anyway, the number and position and subtract. Then we get the vector between the number and the particle. Now we're going to make a distance. And the reason we want the distance between the particle and the number is because when the distance is less than 0.1, that means that, or actually, as long as the distance between the particle and the number is greater than 0.1, it's going to be alive. So now you see they're going to be eaten up, and you see they are counting down. So that's super nice. It works. And here in the, so that works. That's super nice. And actually here I would like to make a multiplier. So this part here is setting the velocity, and I would like to have a multiplier with 2, so it gets a little bit faster. So let's make these candies have a really nice color, and I'm gonna make a vector. And if I do in the color like this, we get black and white. So that's super nice, and I'm actually gonna have it between 0 and 0.8, and here I'm gonna have it in the red channel. And then if we make a copy of these ones, I'm gonna show you what happens, because we want it random in red, green and blue. But you still see it's the same value, and that's because this one returns the exactly random number as this one and this one. And that's because the constant is ticked in. But now all of these three will return a random number. So here you have it. And we need to address the beans. They are a little bit uniform, like in the same angle. So in this initialized particle, we're going to set the angle. And here we're also going to have a random number. And we're going to rotate between negative 180 to 180. We're going to have it, let's see, in the I direction. So now they will be scattered all over the place like this. So let's click play and play one time and see how it looks. So we can see it like this, and if we run around, I'm gonna wait till my Xbox controller start waking up. And here it works. Oh no, please don't crash. Good. So now we see it works. And some of the particles are going a little bit slow. I'm not entirely sure why that happens. I'm gonna pause and try to debug that. Oh yeah, I know what it is. I forgot one thing. So if we do this eat bool thing, and we actually, just for debugging purpose, we put it into color here. And that didn't work, so we're gonna make a lerp. You can't have a bool inside into the color. But you can plug it into a lerp. Now, whenever ETH is true, it will become 1 and then black. So if you look into the, if you see here, when I move this one, it actually do get white in the beginning. Then it gets black again. And that's because here in this one, we set the ETH to true if the distance is less than 0.3. But we only want to do this once, because then when it starts to go away, it gets false. And then when it gets false, this one is false and deactivate the set velocity. So what we want to do, as soon as it activates the set velocity, we want to deactivate this one. So what you want to do, you want to get the ETH bool and make it inverse in here. So you can't, I haven't found any inverse bool thing, but I do know how to make it. So if we do a lerp, so now if it's false, we get a 0, and if it's true, it's 1. So now we just do 1, 0. So now it's inversed. So now you will see it becomes white and stays white. And so this setup here is way too much. So we should do 0.1. So we're gonna multiply. This is the distance, well, the direction that we plug into the velocity here. So we're just gonna normalize it to 1. And then we multiply it so it's only 0.1 in strength and add it to the current velocity. So now, if we move this around, it will be more like you saw in the first video. Isn't this nice? Super nice. Why it's starting to wobble like this is because it kind of, the distance, this one, the distance is, between the frames, it goes past the distance calculation. So that's why that happens. So now we can move this one back, and we don't, 0.1 is probably fine. So if we move this number a little bit closer, and we could actually clamp this one too. I can show you how to do that. So let's say you only want this, this is the velocity calculation here. And if you want to make sure that this velocity part is not more than a certain velocity speed, you can clamp it. So here, if you do like this, if you do distance and you do normalize, so now the vector velocity is normalized to 1 unit, and here you do the distance on this velocity. And let's see, so I remember it correctly. So when you have the distance, we can do a lerp or a compare actually. Am I doing right? Oh my god. So, wow. Lerp. So, if the distance of the velocity is more than, let's say, speed of 1 unit, then it will take the normalized value. So what I think I'm thinking correctly here. So this lerp, it will always take 0. This is if it's less than 1 in speed, it will use this one. But whenever the value if the distance is more than 1, then this input will tell to use the normalized one. So it will never go faster than 1 unit. So it should work, and 1 unit isn't super fast. Oh, and also because we have in the, okay, let's see here. If we restart this one, so we have it in the start function, and I moved this number here, and because start only happened once, this thing wasn't updated. So if we actually just move it to update, then it's less optimized code, but that's fine. Then it will work. So it will be a little bit slow, not super sexy, but I'm going to show you it works now. So now it's updating all the time where the number is. So look at this. Yeah, we should change the speed. Oh my, it's a little bit too boring. So here, when we normalize the speed, we're gonna actually, when the strength is more than 2, then we do this one, multiply also with 2. So now it's gonna be a little bit quicker. So let's try it one more time, or maybe 4. Yeah, that's fine. So I'm not gonna do more with this, but now you see it works. It's perfect. So this is how you do. Really good. Now I kind of showed you how to count the particles. You can make a really cool game about that, I guess. And you can tweak this and do a lot of fun stuff. So I really hope you liked it, and thank you so much for watching.